Example 5. You have a checking account and a money market account at a local bank. Your checking account has a constant balance of $200, and then the table shows the total balance of the accounts over time. Now, before we read part A, keep in mind that the table over here, they said, is showing us the total balance of the accounts. So it's taking into account here the checking account plus the money market account. Part A, write a function m that represents the balance of your money market account after t years. So here they just want the money market. Now, in order to find that, before we get into this, I'm actually going to separate out the two accounts. That way we can just look at the money market. So down here, we're going to make two tables. We're going to have time. And then the first one I'm going to do is I'm going to do the checking account. Then I'm going to do another one. And I'm going to have time. And this one I'm going to make the money market. Now, the time period they gave us was from 0 to 5. Same idea here. And then I'm going to go read. And they specifically said that the checking account has a constant balance of $200, which means, okay, well, I put $200 in, and it has a constant balance, which means it's always 200. So 200, 200, which means in this checking account, you're not making any interest. You're not putting any more money in. You're just putting the money in. It's always $200. However, that's going to work out. Now, your money market account is whatever's left over. So over here, we have a total balance. Year 0, you have a total balance of $300. And 200 of that is in the checking account. Well, then how much has to be in the money market? 100, because 100 plus 200 is 300. The other way to figure that out, 300 minus 200 is 100. So if we move on to year 1 and I have a total of 310, well, that means that 200 plus 110 would have to make my 310. So if I move on to year 2, I'm going to take 321 minus 200 that's in the checking, 121. Year 3, $333.10 minus 200 is $133.10. Year 4, 346.41 minus 200 is 146.41. And then year 5, 361.05 minus 200 is 161.05. Okay, now that we know how much money is just in the money market account, I'm going to go back to part A because it says write a function m that represents the balance in the money market account. So looking at the money market account, we go from 100 to 110. Well, that goes up by $10. Then we go from 110 up to 121. Well, that goes up by $11. So it's not constant. We went up by 10, then we went up by 11. So I know it's not linear. So maybe it's exponential. So I have to figure out what you multiply 100 by to get to 110. Well, let's see. If I take 110 divided by 100, that gets me 1.1. Well, what happens if I take 121 divided by 110? That gets me 1.1. Let's try again. What if we take 133.10 divided by 121? Well, that gets me 1.1. So it looks like my common ratio is 1.1. We're multiplying by 1.1. And we know that it's going up. So this is exponential growth. I know that exponential growth is y equals a times 1 plus r to the t. In this case, instead of using a y, I'm going to use an m. So m equals A is our starting amount. So at year 0, I have $100 times 1 plus R. Now, this is where we get a little bit tricky because 1 plus R, I need my growth rate. And my growth rate actually is not 1.1. My growth rate is like 10%. This 1 plus is already here. Okay, this is already 1 plus R, which is like 1.1 plus 10%. So when we substitute this in, we're just going to leave the 1.1 and then to the power of t. Now, it's always a good idea to check your function. I'm going to check it with this point right here. So I'm going to substitute in 0. If I do m equals 100 times 1.1 to the 0, that's going to get me m equals, grab your calculator, 100 times 1.1 to the 0 is 100. So I substitute 0, I get out 100, check. That's your function for your money market account. Now, part B, write a function B that represents the total balance after t years. Compare the graph of M to the graph of B. Okay, well, let's start with, first of all, write a function B that represents the total balance. Well, the total balance, if you remember, how did we get it? We got it from taking the money market plus 200 to get that. And then the money market plus 200 to get that. And then the money market plus 200 to get that. So if I want a function, I'm going to start with the money market function. So the money market function is 100 times 1.1 to the power of t. But then I always add on what's in the checking account. And what's always in the checking account? $200. And that will give us our total balance, which they're saying to represent by a big B. Now, it wants us to compare the graph of M to the graph of B. I'm not actually going to draw these graphs. They're kind of large, but we're going to think about it. If I were to graph M, and then I were to graph B, what's the big difference here? And the big difference, we're not going to get too into it, but it's the plus 200. So first of all, we can see B is always 200 larger than M. We could probably say something about the horizontal asymptote being moved up by 200. But ultimately, what I would be looking for here is that the total balance is always going to be $200 more than what's in the money market account.